In this video, I'm going to go over a copy of the final exam preparation quiz. The first question on the final exam will be just like this one here, and there'll also be a few formulas there for you to use while you're taking your proctored final exam. All right, so let's get started. Which of the following does not describe the standard normal distribution? The total area under the curve must equal 1. The graph is uniform. This does not describe the standard normal. Which of the following is not a requirement for a density curve? Which one of these is not a requirement? For a density curve, that it's centered about 0. That is not a requirement. The others are a requirement. Question number 4. I have a detailed solution for this one because I drew a little picture. So the waiting times between a subway departure schedule and the arrival of passengers are uniformly distributed between 0 and 8 minutes. Find the probability that a randomly selected passenger has a waiting time greater than 2.25 minutes. So for the uniform distribution, we can visualize with a rectangle, and along the x-axis I've put the increments from 0 to 8, and so therefore, since there's 8 increments there, the height of the rectangle must be 1 over 8, which is 1 over the range, and we want to find the probability the waiting time is greater than 2.25 minutes. So we basically want to find this area up here divided by the total area. So how much time is there from 2.25 minutes to 8 minutes? And we find there's 5.75 minutes. So we want to find the probability that the waiting time is greater than 5.75 minutes. So we take 5.75 times 1/8. And if you simplify that, you get 0.719. Which of the following is not true? A z-score is an area under a normal curve. The z-score is not the area. Remember, the z-score is the relative position of this value that you're interested in. The area in any normal distribution is bounded by some scores. X is the same as the area bounded by the equivalent z-score in the standard normal distribution. That one's correct. C is also correct, that the z-score is a conversion that standardizes values from the normal distribution to the standard normal. And finally, if values are converted to standard z-scores, the procedures for working with all normal distributions are the same. So the correct answer here is A. Where would a value separating the top 15% from the other values on the graph of the normal distribution be found? On the top of the curve, at the center, on the right, or on the left side? And so this is going to be on the right side. If you think about that, this is like the 85th percentile, and it's going to be somewhere up here, so it's going to be on the right side. The standard deviation of the distribution of sample means is equal to, and in this case, that's the first choice there. And then number 8, if a sample size is less than blank, the sample size must come from a population having a normal distribution in order to follow normal distribution calculations, and the answer there is 30. Which of the following is not a procedure for determining whether it's reasonable to assume that the sample data are from a normally distributed population? And of all those, we have a histogram we can look at. We can look at the normal quantile plot. We can identify outliers. But choice B is not something that we'd say, checking that the probability of an event is 0.05 or less. So the normal quantile plot shown to the right represents the duration of times in seconds of eruptions of a certain geyser from the accompanying data set. Examine the normal quantile plot and determine if it depicts sample data from a population with a normal distribution. So if we look at that, we see it's not normal. So we can eliminate answers B and D. Why isn't it normal? It's not normal because there is a systematic pattern there, but it's not close to a straight line. So the correct answer there is A. Which of the following groups has terms that can be used interchangeably with one another? And the choices there, the second choice is the best one. Percentage, probability, and proportion all can be used interchangeably. Express the following, the confidence interval, in this form here. So I'm going to go over to my detailed solution for number 12. So we've been given the interval, and we know that we can find the point estimate because it sits right at the middle of the interval by taking the lower bound plus the upper bound and dividing by 2. And when I do that, I get the point estimate to be 0.666, which would go here in the first block, 0.666. And then I'm going to go plus or minus, and now I need the error, and that's going to be the upper bound minus the lower bound divided by 2, and that's going to be 0.222. And we'll stay over here for another detailed solution. Similar kind of a problem here. They've given me the confidence interval and they want me to find the margin of error and the point estimate. And by the same types of calculations, you can see the answers here. The point estimate is 0.709 and the standard error is 0.013. Okay. A study of 938 decision to grant parole or not made by a parole board produced the following computer output. Assuming the cases are representative of all cases that might come before the board, what can be concluded? So if we see the confidence interval there, we're 90, and it's a 90% confidence interval. So remember, we always say we're 90% confident that the proportion of all paroles granted. So we're not going to talk about the sample, but we're going to talk about all. And so in this case, the correct answer is going to be D. We're confident that the proportion of parolees granted by the board is between 54.9 and 62.7%. What is the best point estimate for the sample mean, for the population mean rather? I gave the answer away there. It's the sample mean. Refer to the accompanying data display that results from a sample of 130 U.S. adults whose body temperatures were measured. Write a statement that correctly interprets the confidence interval. So again, we're talking about a confidence interval here. It's a 99% confidence interval. So we have 99% confidence that, and again, we're going to talk about not the sample mean, but we're going to talk about the true value of the population mean. And so the correct answer for this one is going to be A. Which of the following is not an equivalent expression? I'm going to go over to my detailed solution because we need to take a look at these. So here's the confidence interval we were given, 161.7 to 189.5. So some of these are written as the point estimate plus or minus the margin of error. So we need to figure out what the point estimate is for this interval, and it comes out to be 175.6. And then I'm going to find the margin of error the same way, upper bound minus lower bound over 2, and I see that it's 13.9%. So choice A is an equivalent expression. Choice C is also an equivalent expression, and choice D is an equivalent expression. The one that is not is B, because it starts with the lower bound and then it's adding or subtracting the length of the confidence interval, which is not what we're looking for. The blank hypothesis is a statement that the value of a population parameter is equal to some claimed value, and the correct answer there is the null hypothesis. A type 1 error is the mistake of what? The mistake of rejecting the null when in fact the null is true. Okay, number 20 has a lot of pieces, so I'm going to do this one over here. The claim is a minority of adults would erase all of their personal information online if they could. A software firm survey of 464 randomly selected adults showed that 38% of them would erase all of their personal information online if they could. Express the original claim in symbolic form, and then let the parameter represent the adults who would erase their personal information. So the original claim is going to be a minority. So this is going to be, that's going to be P is going to be less than 0.5. And then identify the correct null and alternative. So the null is going to be that P is equal to 0.05, and our alternative rather is going to be it's less than 0.05. Express the null and alternative in symbolic form. An entomologist writes an article in a scientific journal which claims that fewer than 16 in 10,000 male fireflies are unable to produce light due to a genetic mutation. Use the parameter P, the true proportion of fireflies unable to produce light. Okay, so that we know that our null is always going to be equal to, so it's going to be either B or D, and he's claiming that fewer than, so the correct answer here is going to be choice B. And the same kind of situation here, the entomologist is writing that article. In this case, he's talking about 3 in 10,000. And assume the hypothesis test to test this claim has been conducted and the conclusion is to reject the null. State the conclusion in non-technical terms. So if we reject the null, then we have sufficient evidence to support the claim that, and in this case, the claim that the proportion is less than. So the correct answer is going to be choice B. Okay, on this one, we're going to use a significance level of 0.05, And we want to answer parts A and B. The claim is that less than 44% of adults would erase all of their personal information online if they could. The hypothesis test results in a p-value 0.1656. Okay, so first thing you want to do is compare that p-value to the alpha level. And remember, if the p-value is low, the null must go. This is not less than alpha. So therefore, we would fail to reject because the p-value is greater than alpha. So the correct answer is D. So what would we say this in non-technical terms? So there is not sufficient evidence to support the claim that the percentage of adults that would erase all of theirs is actually less than 44%. So the correct answer is A. Identify the type 1 and type 2 error in the correspond to the giving hypothesis. The principal of a school claims the percentage of students at his school that come from single-parent homes is 11%. Okay, so type 1 error, remember that means we reject the null when in fact the null is true. So that would mean we would reject the claim that the percent is 11% when in fact the percentage is actually 11%. So that's choice B. The type 2 means we fail to reject the null when in fact the null is false. So what would the answer here would be, we fail to reject the claim that it's 11% when it's actually, in this case, different from, because we were testing simply equal to and not equal to. Which of the following is a requirement for testing a claim about a population proportion? So let's see that. We have a stratified sample, no. We have NP and NQ greater than or equal to 5. Trials are dependent, none of these. Correct answer here is B. That is a requirement for testing about a population proportion. Okay, number 26. A poll of 2,057 randomly selected adults showed that 94% own their cell phones. The technology displayed below results from a test of the claim that 90% own their cell phones. Use the normal distribution as approximation to the binomial and assume a 0.05 significance level to test parts A through E. So first of all, is this a one-tail or a two-tailed test? So it's a not equal to alternative, so it's a two-tailed test. Where's the test statistic? Okay, the test statistic is the z, and it's 6.74. And what's the p-value? It's basically 0. And what's the null hypothesis? So the null hypothesis here is equal to 0.9, and our alternative is going to be, oh, I'm sorry, they just want you to come up with your conclusion here. And we are using a 0.05. Since our p-value is so small, we're going to reject the null because the p-value is less than alpha. And what is our conclusion? There's significant evidence to warrant rejection of the claim that 90% own a cell phone. All right, some more writing hypotheses. Do you believe that Loch Ness Monster exists? Among over 22,000 responses, 65% were yes. Use an 0.05 significance level to test the claim that most people believe the Loch Ness Monster exists. How is the conclusion affected by the fact that internet users who saw the question could decide whether to respond? Okay, so most people is going to mean greater than 0.5, and so we're going to have the null be p equal to 0.5, and the alternative is going to be greater than 0.5, which is choice B. The statistic was 44.7, and the p-value was very small. So we're going to reject, and we're going to conclude that there is evidence that most people believe the Loch Ness Monster exists. And what about the idea that this was internet users? So then, since this is a voluntary response, we probably are wondering if the conclusion is really valid. Which of the following is a characteristic of the t-test? It's the same for different sample sizes, not true. It has degrees of freedom equal to the sample size, no. It's equal to the sample size minus 1. It's bimodal, that's not true. And it is robust against departures from normality, and that's true. And that's one of the reasons that we use the t-test rather than the normal distribution when we're working on these problems. Okay, so number 29. Degrees of freedom. We want to know what the degrees of freedom are for this particular problem. They had 475 random tornadoes, and we're going to test that the mean tornado length is greater than 2.5 miles. The degrees of freedom, remember, n minus 1, so this is going to be 474. And then we're going to write some hypotheses again. A bus company official claims the mean waiting time for bus number 14 during peak hours is less than 10 minutes. Karen took that bus on 18 different occasions, and her mean wait time was 7.6 minutes with a standard deviation of 2.3. At the 0.01 significance level, test the claim that the mean waiting time is less than 10 minutes. So what's the null and alternative? Okay, so we don't look at Karen's data when we write the null and alternative. We look at what the claim was, and the claim was that it was less than 10 minutes. So therefore, the null and alternative hypotheses are going to be E. And then the test statistic was t equal to, S was t equal negative 4.427 with a p-value less than 0.01. Identify the conclusion using a 0.01 significance level. Okay, so our p-value is less than the significance level, so we're going to reject the null, and we're going to say there is sufficient evidence to support the claim that the mean waiting time is less than 10 minutes, which is choice C. Researchers investigated the magnitude of recent earthquakes in California to determine if the magnitude was different from the historical mean of 2.75. And here's the 95% confidence interval shown right here. Using the confidence interval, they want to test the null hypothesis that is equal to 2.75 versus not equal to. Would they be able to reject the null based on this confidence interval? So when we look at the confidence interval, it goes from 2.52 up to 2.62. 2.75 is not in there. So that would allow us to reject the null hypothesis, since that magnitude of 2.75 does not fall within that interval. Smoking and episodes of lung cancer have high correlation, but this does not prove causation. Remember, correlation does not mean causation. The scatter plot shows admissions, acceptance data, and the student-teacher ratio collected from a random sample of private schools in Pennsylvania. What do you see? Is there a relationship in that? I'm sorry, that should say between the acceptance level and the student-teacher ratio. Describe that relationship. So what do we see there? We really don't see much of a relationship. There doesn't appear to be an association there, so the best answer here is going to be B. Which of the following is not a property of the linear correlation coefficient? It's between -1 and +1 inclusive, that's true. It's not affected by the choice of X or Y, that's true. It measures the strength of a linear relationship, that's true. It's robust. A single outlier will not affect it, that's false. A single outlier will greatly affect, usually, the correlation. The accompanying scatter plot shows internet usage in hours per week and age for a random sample of U.S. adults. Considering all of the data, which of the following is the most reasonable estimate of the correlation for these data? So we notice that as age increases, the internet usage time decreases. So we're looking for a negative correlation, and it's a fairly strong one. So the best estimate would be A. Which of the following is not equivalent to the other three? So independent, explanatory, and predictor are all basically the same explanation of the variable. The dependent variable, if you think about it, would be the y variable when you're graphing like on a scatter plot. So on this one, it says Comcast Customer Service Department asks its customers to rate their over-the-phone service on a scale of 1 to 20. The company then matches the customer's rating with the number of minutes they waited on hold. The data are shown below. Some StatCrunch output is also provided. Is it appropriate to calculate the linear regression equation? If yes, what is the equation? Okay, so we see a pretty fairly normal trend. It's not real strong, but as the minutes increase, the rating goes down, which is what you would expect. So which output do we use? So the dependent variable we're going to be using is the rating. So we're going to be using the second set of output, and then there's our regression equation right there. So it is appropriate, and then there's our regression equation, which is in answer D. Now on this one I have a detailed solution because we have to do a prediction. Suppose the internet retailer buy.com would like to investigate the relationship between the amount of time and minutes a purchaser spends on its website and the amount of money they spend on an order. Some StatCrunch output is provided. Predict the sales if the customer spends 41 minutes on the website. So what you need to figure out is which is the right output to use. So we're trying to predict the order size based on the time spent online, and that's going to be the second set of output right here. And so what you're going to do is you're going to use that equation here, I've written it down here, and we're going to substitute in for time 41 minutes. And when I do that, I come out with a predicted order size of $231.16, which is answer D. Which of the following is not true for conducting a hypothesis test for independence between the row variable and column variable in a contingency table? So the degrees of freedom is r minus 1 times c minus 1. That's true. The null hypothesis is that the variables are independent. That's true. Small values of the chi-square statistic reflect significant differences between the observed and expected. That's not true. We're looking for large values. Tests of independence with a contingency table are always right-tailed, and that's true. Tests for adverse reactions to a new drug yielded the results in the table. The data will be analyzed to determine if they provide sufficient evidence to conclude that an association exists between treatment, drug or placebo, and the reaction, whether or not headaches were experienced. Which of the following is the correct null and alternative? So remember, the null is always going to be that they're independent of one another. So we look down here and we see, or no relationship. Let's see, independent. So I see that in A, and so my best choice here is going to be A. So the alternative is either not independent or dependent, and I see that in choice number A. The table below shows the age and favorite music type of 668 randomly selected people. If we conduct a chi-square test of independence, how many degrees of freedom are there? So notice row minus 1 times column minus 1. So I've got 3 rows, so r minus 1 is 2. I've got 3 columns, so 2 times 2 gives me 4 degrees of freedom. And on this one, we're going to do an expected cell count, so I have a detailed solution for this one. So we want to do the table below from a study with the stated objective of addressing cell phone safety by understanding why we use a particular ear for cell phone usage. We want to test the claim that handedness and cell phone ear preference are independent of each other. Assuming handedness and cell phone preference are independent, calculate the expected cell count for right-handed no preference. Round to 2 decimals. Okay, so right-handed, so we need to get the row total for right-handed, and I went ahead and I got that as 642. And I need no preference to column total, which is 43. And I need the grand total for the table, which is 711. So I take row total times column total divided by overall total, and I come out with 38.83 for the expected cell count for that particular cell right there. Responses to a survey are broken down according to gender. The sample results are shown below. At 05, test the claim that the response and gender are independent. And they gave me the chi-square statistic here and the p-value here. And what are we going to do? So we're going to use a p-value, an alpha level of 0.5. Yeah, 0.5. And so we've got a p-value that's not less than 0.5. So our chi-square is greater than 0.5. And so the correct answer here is we're going to fail to reject, which is answer B. I'm sorry, that's not correct. It's not the chi-square value, it's the p-value, it's answer D. Since the p-value is greater than 0.5, we fail to reject, not the chi-square, the p-value. And that's the end of this video. So I hope this helps you prepare for your proctored final exam.